All right, before we begin, don't forget next week, Thursday, is the AMC test. You have to report at 7:20 to the lower gym. And then I'm also thinking of curbing the semester exam. I'm thinking of it. I will give you my final decision on Tuesday. Anyway, I'm thinking of using this formula right here that I devised. So whatever score you got, you just put it in for X and boom, you get your new score. So what it does is, it gives, the lower your score is, the more points you get. Well, you actually gotta, anyway, so what happens is, if I did that, the average will go from 82 to 86. That's pretty decent, no? I would say probability 0.9 that will actually implement that. I'll tell you for sure on Tuesday. All right, today we move on to matrix 2. So last night, one of the things that you had to do was you had to find the inverse of a matrix, right? Like, if you have matrix A, I just like to use 2, 3, 5, 7. First 4 prime numbers. How do you compute A inverse? Well, if you have a matrix A and you multiply it by its inverse, what are you going to get? What did we learn last time? I. Remember the one that acts like the number 1? So you actually did it twice on last night's homework, but maybe you didn't realize that that's what you were doing. So if you have a matrix 2, 3, 5, 7, what do I need to multiply it by to get I? Remember that's I? The one that acts like the number 1? So what did you do on last night's homework? Didn't you go A, B, C, D over here? This is the ABC method. And then what you have to do is you have to solve 2 sets of 2 equations, 2 variables. And you did that, right? There must be a better way, Mr. Park. Well, for a 2 by 2, we have a theorem. Okay? So, starting from tonight's homework, you don't have to do the ABC method because it takes a while, right? But this theorem only works for 2 by 2 now. So here is the theorem. If matrix A is equal to A, B, C, D. Oh wait, before I even tell you this theorem, we gotta review something that you learned last year. Now the other classes told me you guys learned Kramer's rule last year. Does that sound familiar? Kramer's rule. How come some people say yes and some people say no? So you have a matrix like this, A, B, C, D. What does it mean if you just have straight bars like this, A, B, C, D? You guys remember? So this is a matrix. When you put the straight bars around it, that means the determinant of the matrix. Now, if you guys learned Kramer's rule last year, then you had to have learned the word determinant. You actually have to know this on the ACT, I think. Okay? So, so straight bars means determinant, brackets means it's the matrix. Now, to compute a determinant, does this look familiar? A times D minus B times C. This times this minus this times this. Oh boy. Okay, so let me give you an example. Let's put some numbers in. 3, 4, 5, 7. How do you now, do not get confused between a matrix and a determinant now. A determinant is an operation performed on a matrix that produces a number. But the thing is, you can do lots of things with this number. So if you have something like this, to compute the determinant, you simply go this times this minus that times that. 21, here, I'll even do it. 21 minus 5 times 4, 20, and what do you get? 1. See, it's a number. But you can do lots of good things with this number. So it doesn't matter if you can remember or not. I mean, that's what you're going to have to know now. So now I can teach you the theorem. If you have a 2 by 2 matrix, to compute the inverse, all you have to do is go 1 over the determinant of matrix A, switch these two, negate those two. This is a lot faster than doing the ABC method, because how long did it take you to do last night's homework? There was homework last night? Probably if you had to solve the two sets of two equations, two variables, it'd take you like, I don't know, four minutes to do one problem. But this one, you can do it in less than 30 seconds. Example, what if matrix A is equal to, give me some numbers, 3, 4, 5, 6 then. To compute the inverse, instead of doing the ABC method, you just go 1 over the determinant. How do you compute the determinant of this? This times this minus that times that. You can do that in your head, right? 18 minus 20. -2. You switch these two. You negate those two. Finished. And if you want to, you can take the -half and put it inside. Remember, how do you multiply a matrix by a number? You multiply every element with a number. So if you want to, you can go -3, 2, 5 halves, -3 halves, or you can just leave it like this. There's nothing wrong with putting the number on the outside either. So which way do you like better? I think this one, yeah, but then you gotta know more things, yeah? So from now on, if I ask you to find the inverse, just use this. It's way faster. But on tonight's homework, look at number 4. You have to compute the inverse of a 3 by 3. We don't have a theorem for that, so you have to use the ABC method. So here, let me set up number 3 for you, because some of you just basically do the same thing here. I'm not going to do it for you. You're going to have to do the algebra. So here's matrix A. What does it say? 1, 1, 2, -1, 1, 1, -2, 3, 3. Find the inverse. So, how do you find the inverse? What do I need to multiply this by so that I get I, which is 1, 0, 0, 0, 1, 0, 0, 0, 1? I don't know. So we'll call it A, B, C, D, E, F, G, H, I. That's how you do tonight's one. So you're going to end up solving 3 sets of 3 equations, 3 variables. Now, is there a faster way? Well, it's a little faster, but you still got to do work. But we got to learn some more stuff before we can do it. Okay, and then what else do I have to teach you today? Oh, solving a system of equations. Oh, too bad we got to stay on one side of the board here. Okay, so why do we learn matrices? Just so teachers have jobs? No, because there's, especially in computer programming, there's so many applications of it. One of the, probably the most important application is solving systems of equations. Now, I'm going to show you how it works on 2 equations, 2 variables, but in real life, if somebody gives you 2 equations, 2 variables, you just use algebra 1. In fact, if you have 3 equations, 3 variables, use algebra. Once you get more than that, like when you go to college, if you take like statistics or psychology courses, sometimes you got to solve like 20 equations, 20 variables. What do? You take out your graphing calculator and do what I'm going to show you here. Okay, but this, see, so what, I'm going to show you how it works on 2 by 2, but you can apply it to n by n, yeah? So, how about 2x plus 3y equal 4, 5x plus 6y equals 7. I'm not sure how that's going to come out. I didn't put any thought in that. Okay, solve this using matrix methods. So watch what I'm going to do. Like I said, in real life, if somebody gives you this, just use algebra 1. But if you have 30 equations, 30 variables, then you do this. Matrix A is equal to 2, 3, 5, 6. Where did I get those numbers from? Those are the coefficients of the variables, yeah? Matrix X is the variable matrix, and matrix B are the constants over here. Okay, now this is the part that you have to understand. So if I define these 3 matrices right here, then A times X equals B is the representation of this. Okay, so since this is the first time I'm teaching you this, okay, let's try to understand this. How do you multiply A times X? Can you multiply this times this? This is 2 by 2. This is 2 by 1. Can you multiply them?
Yes.
Yeah, and what is the result going to be? 2 by 1, okay? So go across and come down. 2x plus 3y. And then go across and come down. 5x plus 6y. And that is equal to b, which is 4, 7. And the only way the two matrices can be equal is if this equals that and this equals that, right? Isn't that the same thing as this? So this is simply the matrix representation of that. So, what did we learn last time? How do you solve for matrix X using matrix algebra? How do I get rid of an A here? Multiply by A inverse on the left. So, A inverse B. There you go. And then see, matrix X is this. So once you get this, then the top number is the X and the bottom number is the Y. And then you solve the system. Okay, so now, so to do this method, everything depends on can you find the inverse of a matrix. Well, here's matrix A. How should I find the inverse? Should I use the ABC method or the theorem that I just taught you? Use the theorem that I just taught you, okay? How do you find the inverse of this? 1 over the determinant of this. What is the determinant of this? This times this minus that times that. 12 minus 15. Negative 3. Switch these two. Negate those two. That's way faster than the ABC method. And then multiply it by matrix B, which is 4, 7. So once you do this, that's going to be the answers to the problem here. Now, it's up to you if you want to distribute the negative 1/3 in here, but I'm telling you, don't. You know why? Because you're going to get fractions. So why not just multiply these two first and then put in the negative 1/3? So let's go over here. So if I were me, I would do this. And again, when you multiply a 2 by 2 to a 2 by 1, you're going to get a 2 by 1, right? So let's do it. Go across and come down. 24 and negative 21 is 3. Right? Okay? Negative 20 plus 14. Negative 20 plus 14. Negative 6. And then now I'm going to go up here. Now, how do you multiply a matrix by a number? Multiply each element by that number. So you get negative 1 and 2. So that's the solution to the system. That means these two lines intersect at the point negative 1, 2. But like I said, it's the part that, yeah, in real life, just use algebra 1. 3 equations, 3 variables, use algebra 1. When you get to 4 equations, 4 variables, then you got to think, oh, maybe I should use this matrix thing because I can do it on my calculator. I'm going to show you how later. Actually going to do exactly what I just showed you now. So that's what you're going to do on tonight's homework, okay, for number 3. Okay, last thing. So we know how to compute the determinant of a 2 by 2 matrix, but what about 3 by 3 and 4 by 4? Yes or no? You guys learned 3 by 3? Now, if you learn Kramer's rule, it just depends. Did your teacher give you only 2 equations, 2 variables, or did he give you 3 equations, 3 variables? You guys remember? Well, it doesn't matter because I'm just going to teach you like you don't know anything. All right, so to compute the determinant of a 2 by 2, like this, of course, you guys know now, right? You just go A times B minus B times C, very easy. But what happens when you have a 3 by 3? Like here. Let's put some numbers in. 1, 2, 3. 3, 2, 4. 2, 1, no, 2, 3, 1. How do you compute it? See the straight lines? Determinant? Okay, so this is what, I need my ruler here. I need a ruler. Actually, I need 2 rulers, but I don't have 2 rulers. Just use this then. Okay, so to compute the determinant of a 3 by 3, what you're going to do is pick any row or any column. That's the beauty of this thing. Any row or any column, it doesn't matter. Okay, like let's just go across the first row. So what we're gonna do, if you read your notes, multiply each element by its cofactor. Now what the heck is a cofactor? That's what you gotta know. Okay, well, a cofactor is -1 to the I plus j multiplied by the minor. Okay, but now, what is the minor? Well, every element in this matrix there's 9 elements, has a minor. To compute that minor, okay, so what would be the minor of this element here, which is in the first row, first column? You simply cross out the row and the column that you're in. Does this look familiar? No, then you didn't learn it then, okay? So, what's left after you cross it out? A 2 by 2. And then the determinant of what's left over is called the minor. So what is the minor of this element up here? This times this minus that times that. 2 minus 12. -10. So the minor of this element is -10. You gotta cross out the row and column that it's in. Okay, what about this element right here? This 3 at the bottom. Cross out the row and the column that it's in. Compute the determinant of what's left over. 4 minus 9. -5. That's the minor. You guys get it? I think we're going to do one more. What about this 4 right here? What would be the minor of this element? Cross out the row and column that it's in. And what do you get? 3 minus 4 is -1. Okay, now that's how you compute a minor. But a cofactor is the minor multiplied by -1 to the I plus j. What the heck is that? Well, I plus j is the row and column number that it's in. So for example, this one right here, what is the cofactor of this? Well, first you compute the minor. Did we do this one already? 3 minus 4 is -1. But now you have to multiply it by -1 to the I plus j. So you got to multiply it by -1. And what is I plus j? Again, it's the row. What row is this in? 2, 3. So 2 plus 3. What is -1 to the 5th power? -1. And what's -1 times -1? 1. So that's what the cofactor is. So the cofactor is simply the minor multiplied by either 1 or -1, right? Because if I plus j is even, it's 1, right? If I plus j is odd, then it's -1. In fact, if you learned this last year, your book showed you this. Does this look familiar to some of you? Some of you nodding yes, most of you going, no, doesn't matter. You know what this is in your book? This tells you whether to multiply it by either +1 or -1. Because the upper left-hand corner is 1, 1, right? 1 plus 1 is 2. And the next one will be 1, 2. 1 plus 2 is 3, which is odd. That's why it's minus. So this checkerboard thing just tells you whether to multiply it by either 1 or -1. And then if you have more, then you just expand the thing like this. Like if you have a 4 by 4. It's just a checkerboard. The upper left-hand corner is always plus because it's 1 plus 1, that's why, right? Okay, I think we better do some more. What about this element right here? What is the cofactor? Well, it would be the minor. Okay, let's compute the minor first. Cross out the row and column that it's in. What do you got? 8 minus 6 is 2. And then do I multiply that by 1 or -1? 1. Right? Because this is in a positive position. Because isn't this third row, first column? 3 plus 1 is 4. It's even. -1 to an even number is 1. So then the cofactor is 2. So again, the cofactor is simply the minor multiplied by 1 or -1. And the negatives are going to be these positions right here, right? Just like the checkerboard, right? Okay, now that I define all this, now we can finally actually compute it. Okay, so like I said, select any row or any column. Let's select the first row. How much time we got? We've got 10 minutes. Oh boy. Okay, so we're going to multiply each element 1, 2, and 3 by its cofactor, and then we add them all up. Okay, what is the cofactor of 1? Cross out the row and column that it's in. Let's make this look better. What's the minor? 2 minus 12. Negative 10. Now do I multiply that by 1 or negative 1? 1. So what is negative 10 times 1? Negative 10. Just put the cofactor in there. Okay, next element is this. Cross out the row and column that it's in. What is the minor? 3 minus 8. Negative 5. Now do I multiply that by 1 or negative 1? Negative 1. So negative 5 times negative 1 is positive 5. Okay? You got to keep track of those plus and minus signs now. And then what is the minor of this? Cross out the row and column. 9 minus 4. 5. Multiply that by 1 or negative 1? 1. So 5 times 1. 5. Add them up. Okay, let's do it right here. Negative 10 plus 10 plus 15. 15, there you go. That's the determinant. The determinant is a number. But like I'm telling you, you can do plenty of things with these numbers. That's why we're learning it. There's so many applications of it. Yeah, but Mr. Park, you said you can pick any row or any column. That's right. Like, what if I said, oh, I want to come down the second column because 2 is my favorite number. Okay, it doesn't matter. It's still going to come out to 15. That's the beauty of this thing. Okay, so we're good. Now, watch what I'm going to do. Now I'm going to show you the way the pros do it, okay? This is just how they define it in the books. I'm going to show you how the pros do it now. So I'm going to come down this column. Watch what I do. That's 2. How come you put a negative 2, Mr. Park? Because you're going to have to multiply down by negative 1. See, because isn't that the negative position? Then how come you put a plus sign on this one? Because that's the positive position. How come I put a minus sign on this one? Because that's the negative position. So you're going to have to multiply by negative 1. So why not put the signs in before you start, and then you don't have to worry about it? You know what I'm talking about? Okay, so let's start with this. Okay, let's do this fast. Cross out the right column. Go. 3 minus 8, negative 5. Okay, what about this one right here? Cross out the right column. 1 minus 6. And then what about this one down here? 4 minus 9. Negative 5. So what do we got? We got 10 minus 10 plus 15. That's 15. See how it comes out to the same number? You can pick any row or any column. Of course, if you're smart about it, you can save time, right? What if you had this? 3, 2, 4. 6, 5, 0, 2, 4, 0. Now, if you were smart, which row or column would you pick? The third column, because then you would go 4 times something minus 0 times something plus 0 times something, and these just could be 0, right? So you only have to compute one thing. And again, do you know why I went plus, minus, plus? Because that's plus, minus, plus positions, that's why. Okay, so you only have to compute one thing. Go. 24 minus 10. 14. 4 times 14? That's the problem, Mr. Park. 56. Okay, last thing. Yeah, but Mr. Park, look at number 8 on the homework. What the heck is that? That's a 4 by 4. That's right. Don't worry, we don't go past that in this class. Well, we do, but you get to use your calculator for it. So now that I taught you how to compute the determinant of a 3 by 3, that same method can be applied to anything, n by n. So you can do 4 by 4, 5 by 5, 6 by 6. Let's just do a 4 by 4. Okay, how much time we got? We got 6, 7 minutes. Here, give me some numbers. 1, 2, 3. 1, 2, 3. We don't want to make the numbers too big. So 1, 2, 3. Because they get big really fast. 1, 2, 3, 2. There. Compute this determinant. Pick any row or any column. Now, if I don't see any zeros, like if you look at tonight's homework, yeah, I get zeros here. So if you were smart, which row or column would you pick? The first column, because it's got 2 zeros. That's going to save you time. But when you have something like this, no more zeros, so you just got to pick any row or column. Okay, I'm going to go across the first row then. Okay? That's what I do if I don't see zeros. So multiply each one by its cofactor. So watch what I do. 1 times something minus 2 times something plus 3 times something minus, oh, that's not 4. 1 times something. How come it's plus, minus, because that's the checkerboard, right? Plus, minus, plus, minus. Put it in before you start so you don't have to worry. Okay, here we go. So, what do? I cross out the row and column that it's in. What's left? A 3 by 3. So we got to compute a 3 by 3 determinant. 3, 1, 2, 1, 2, 3, 2, 3, 2. Okay, now what goes in here? Well, this one here. Cross out the row and column that it's in. You get a 3 by 3. Okay, let's see if I can reach over here. 2, 1, 2, 3, 2, 3, 1, 3, 2. Okay, next one. This one here. Cross out the row and column. 2, 3, 2, 3, 1, 3, 1, 2, 2. And then finally, the last one. Oh, shoot. So we can read it to me. No, don't worry about it. 3, 1, 2. No, I got it. 1, 2, 3. There, I did it. So, to compute a 4 by 4 determinant, what do you have to do? You got to compute 4 3 by 3 determinants. So, also, Mr. Park, I have to be good at 3 by 3 determinants. Yes, that's what you got to be good at. Okay, here. So we're going to practice. How much time we got? We got 4 minutes. Okay, here. You guys do the first one. That's just this. Here, you guys do this one. Here, you do this. And then there, you do that. And let's see if you can do it in the time it takes me to do all 4. Okay, go. Hope I don't make a mistake. You guys get those numbers? Okay, yeah, I did it right. Okay, so now you gotta go 1 times negative 13, negative 2 times that minus 26, 3 times that is negative 21, and negative 1 plus 18. So this would be the hard part for you guys. So this is negative 3, and that's negative 39, so negative 42. I wish we had time to check this on our calculator. We've got 3 minutes left. We can check this on our calculator. So, Mr. Park, I gotta, yeah, you're gonna be doing this plenty on the quizzes and the tests. That's why you gotta be good at arithmetic. Okay, so how do you compute a determinant on your calculator? Just do exactly what you did yesterday, except, how do you get determinant? Let's go toolbox, oh no, matrix, determinant. There it is, determinant, and then just punch in the matrix. So remember how we did it yesterday? Go to the template button, click that, and then just put in the numbers. Or you can just watch me do it. 2, 3. Wow. Okay, the race is on. Can I do this before the bell rings? 2, 3. 2. There's gotta be a faster way, huh? Can't you just shout it out and the thing puts it in for you? Don't ring bell. 2, 3, 1. Concentrate. 2, 3. What was the last number? Quick. 2. Okay, click outside and press enter. -18. We did something wrong then. Come on, you guys said you got those numbers. Okay, which one is wrong? This one is wrong. Okay, wait, let's do it again. 2 times, okay, 2 times, oh, this is not 1, that's 4. This is -5. So that's -10. So that's 1. So this is 1. So what does that make this? This means -2. So this is -15, -18 is correct. How come you guys told me you don't? Yeah, I got that. Strike 1. You two on the camera. Strike 1. All right, the bell's gonna ring already. Good, Tuesday. No, not even Tuesday, Wednesday. Wow. Vacation.
Turn back, I'm making before class, so I just think of them when we finish the quiz.
Oh, no, you only have to turn it in at the end of the chapter.